About 5 years ago I built an Eggbot. That's a machine that prints on eggs. It's basically some kind of a CNC machine, super simplified, but still it has stepper motors, it has a servo motor so that it can lift the pen. You have to prepare the, let's say, G-code, it's still a G-code, very simplified G-code. To draw something on an egg, you have to, do a lot of things, you have to build it, you have to program this. So it's very simplified CNC machine, but it's still a CNC machine, so maybe for some of you this is a great introduction to CNC machining. So 5 years ago I used really DIY methods to build this thing. I used some plastic, wood, wires, even Lego bricks, rubber bands, glue. This project was total mess, but it was working. I will use my laser cutter and 3D printer to build this project. Also 28 BYJ, 48 stepper motors, super cheap stepper motors, and of course Arduino. And if you don't have the laser cutter and 3D printer, but you still want to build this project, you have two options. You can build my Eggbot from 2015, from 5 years ago, and if you want to build it as I will do it right now, with laser cut parts and with 3D printed parts, no worries, I will sell those parts on TeamD so that you can build your project and at the same time support my channel. And now I will start with parts that we of course need to build this project. And here I have the parts for this project. As I said, let's start with laser cut parts. Here I have all of them cut on my laser with 3mm plywood. It works really great for this kind of projects, and that will be basically the main case for this project. We have some holes for stepper motors, for USB port on the Arduino. These things right here and those holes right there are so that you can attach this case together, and we'll use for that a little bit of wood glue. Here I also have the holes to attach the Arduino in proper place, and here we have 3D printed parts, as you can see, including one small flexible 3D printed part printed with white flexible filament. We also have 608 bearing, that's very popular in skateboards, really easy and inexpensive to buy. Arduino Uno, but any other Arduino will work. Two stepper motor drivers, I think that's A4988, and one breadboard, really small breadboard. Two stepper motors, 28 BYJ 48, and some breadboard cables. And that's all of the parts for this project. As I said, 3D printed parts, laser cut parts, link to them in the description. Okay, I know that some of you watching this video right now will be like, but you should design a PCB and make this project professional and solder everything. But I don't really want to. Using a breadboard is great because for beginners it is super easy to just plug the stepper driver into the breadboard, connect with few cables to the Arduino, and project is ready. Overall, a good solution for some DIY projects, but before I will get into electronics and programming, I actually have to glue those pieces together with some wood glue. Then we'll let this thing dry and I will focus on the electronics and programming. So the main construction is ready, and it was quite easy to assemble because I spent so much time in Fusion 360 as usual for my projects to design this thing, and assembly is just pure fun. Here is the rod so that we can adjust it to the X size or whatever you want to paint. So it's quite a flexible construction. Here we have the pen holder on a stepper motor. Here is second stepper motor. Here is servo to lift the pen. What else? I will put all of the electronics in here, but firstly I have to develop the electronics and program that. I will attach it to this plywood and then glue the plywood like that on the bottom, so everything will be enclosed in this box. It will be a really clean construction. Here I have the holes for the stepper motors, for the cables, so that everything will be here inside, invisible from the outside. I also will probably redesign this part right here to print it with flexible filament. Here we are, that's day number 2 of working on this project, and so far it's really good. Yesterday I have been working on this thing very long, and today I'm starting very late, but already I can draw some stuff. Right now I tried to draw a basketball on the egg, and it's not really that great, but it's promising. I also connected everything. The Arduino is connected to the stepper motor drivers, to the stepper motors, and I power all of that with my lab bench power supply. The biggest problem right now is the play on this stepper motor on the y-axis, because that's the y-axis for this project. This play is huge, and that's because, you know, 28 BYJ is super inexpensive motor, and because it is super inexpensive it lacks some quality. So I need to fix that. How? I have no idea, but I already disassembled one broken motor, and right now I will also open this one and maybe combine those two to create a better motor. Thanks to that I have only 2 working motors, this and this one, so I hope I'm not going to break any of these. I just thought that maybe disassembling this motor is not the best idea, because as I said, I had just 2 of these, and after disassembling the arm play on the shaft of those 2 motors is exactly the same, so I think disassembly is not really a good idea, but I need to find a better solution. To be honest, as for now, I have no idea if there is any solution to that. Thanks to this rubber band, the backlash problem is smaller. It's still there, but it's not as visible. The problem is that on this axis right here I can't use any rubber band, and the backlash is of course also there, so I think it's a good time to just give up. Not on the whole project of course, but on 28 BYJ 48 stepper motors. I thought those will be perfect for this project, but they are not, I was wrong. And right now I will move to NEMA 17, so tomorrow I will redesign this thing, I will cut that on the laser cutter, we will start assembly again, and hopefully get this machine working tomorrow perfectly. I think it's day number 3, yeah, probably. Yesterday I was in the workshop to cut those parts on the laser, and basically the only difference is the mount for the motor right there and there for NEMA 17, and of course I will link the old design in the description, just if you want to try with 28 BYJ, but keep in mind that this is maybe not the best idea as you saw. And now I just need to glue those parts again together and then go through the assembly process, and hopefully this time everything will work as it should. I'm waiting again for the glue to dry, so let's talk about electronics and programming right now. When it comes to the electronics, just connect everything like on these schematics. I'm using the micro-stepping for stepper motors, so instead of 200 steps per revolution, I have 3200 steps per revolution. That gives me a lot of precision to paint the egg properly. When it comes to the programming, I will use GRBL. I know, maybe an overkill for such a project. There are easier solutions for Eggbot. But I think GRBL is great because it gives you an introduction to CNC machines and it's really not that hard to use. You just download the GRBL from the GitHub and then install it just like any other Arduino library. If you don't know how to do that, just Google how to install Arduino library. You will find a lot of tutorials on that. And you also need to download one thing from the GitHub that will a little bit modify the GRBL so that we will be able to use the servo instead of the motor, stepper motor on the Z axis. And that is called GRBL Pen Servo. I will also link it somewhere in the description or on my website. And basically you just download this thing and paste few files to the directory of GRBL. It's very simple to do. And once you've done that, you just open grbl.ino and install it on your Arduino just like any other Arduino sketch. Super simple to do. Once GRBL is installed, we have to modify some variables to make it work properly with Eggbot. And here in CNCjs, once you are connected to the Arduino, on the left you have console, this black thing right there, and you just have to pass few variables. Here you have $number equals number, and here you have the list of what you have to send. So now let's move on to the Inkscape. In the Inkscape, the best thing that you can do is to set the document width and height to 80mm when it comes to the width and 26mm when it comes to the height. And then in this document you can do anything you want and export it as SVG file. And then we'll move on to JSCAD. And I know, again, an overkill for such a project, but I actually like using the JSCAD for this thing because it gives you a little bit of understanding about CNC machines. You can set up the engraving, milling, a lot of stuff that is quite useful but also super simple to use. It's not overwhelming like Fusion 360, but you can also use Fusion 360 for an Eggbot, and that's a total overkill, but still it works. And it gives you the understanding of CNC machines. You can be more confident with using your next CNC machine after using such Eggbot project that way, so that's great. Right here you just have to choose engrave, generate, save as G-code, and then move on to CNCjs, open your G-code, set up everything and click run. And that's it. So it's super simple to use, it's also very safe, and it's fun, and that's I think the most important in this project. So now let me show you what you can draw on an Eggbot, and that's pretty much it. And that's it for this video. I hope you enjoyed it. Maybe this project was a lesson for you. Maybe you are building your project right now. Maybe it's not working as you would like it to on the first try, but maybe 5 years later you will build exactly the same thing, the version 2, and it will work exactly as you would like it to. That's what I did with the Eggbot. 5 years ago it was totally imprecise, pretty crappy, but right now it works just perfectly. It's super fun to build it. If you need some links, all of them are in the description. The link to buy this kit from me and support my channel that way, link to my Patreon, link to the website where you can read more about this project and find all of the files, of course, for free. And if you have any questions, leave them in the comments. Thanks for watching, happy making, bye!